In this analysis, we're going to trace the absolutely fascinating and, frankly, sometimes perilous software development lifecycle of AI-generated code. Welcome to The Explainer. If you've been using AI assistants to help you code, well, you already know they've completely revolutionized how fast we can build software. I mean, we're taking mere ideas and turning them into working prototypes at lightning speed. But with that incredible speed comes a massive, often totally invisible risk. So today, we're mapping out exactly how to secure your AI coding journey right from that very first local prototype all the way to a live, production-ready application. Let's be totally honest for a second. Have you ever just pasted an API key right into your code, just to see if your prompt actually works? We have all been there. It is incredibly tempting to hard-code a key just to get that quick hit of success. But here's the thing we really need to understand. AI assistants have dramatically amplified the hidden risks of this make-it-work-quickly mindset. What used to be an isolated local experiment now frequently gets pasted back and forth into chat windows, pushed to repositories, and then rapidly deployed. Okay, let's dive into this. First, we'll cover the risk of leaked secrets. Then, local security, least privilege and privacy, secure deployment, incident response, and finally, secure by design. Our goal isn't to scare you with warnings. It's to equip you with highly actionable, professional solutions. Section 1. The risk of leaked secrets and the dangers of AI coding. So, what exactly are we talking about here? When we say secrets, we mean pieces of confidential information. Think API keys, tokens, OAuth credentials. In modern AI apps, these secrets are the glue. They are literally everywhere. They link your code to language models, cloud storage, payment gateways, and data analytics. And because they are the master keys to services that often charge by the request, they are incredibly high-value targets. And this brings us to a really critical insight from OWASP, the Open Worldwide Application Security Project. Managing these secrets isn't just some technical afterthought, it's an organizational task that spans the entire life cycle of your software. In fact, if you look at the OWASP Top 10 for large language model applications, they explicitly highlight risks like sensitive information disclosure and prompt injection. The AI models themselves can actually inadvertently expose secrets if we aren't handling them properly.
Let me walk you through exactly how quickly things can escalate. We call this the blast radius. Minute 1, your local AI prototype works flawlessly because you hard-coded the key. Awesome. 5 hours later, you push your code to a public Git repository. 2 days pass. Actually, sometimes it's just minutes, but let's say 2 days. Automated bots constantly scraping GitHub find your key. 3 weeks later, a massive, terrifying API bill arrives in your inbox because a bad actor has been using your account to run thousands of expensive queries. And the real trap here, even if you go back and delete the key from your main file, Git history permanently retains old commits. If it was pushed, it's compromised.
Moving right along to Section 2, Local Security and Environment Variables.
There is a massive gap between amateur habits and professional practice. On the learning side, you've got hard coding, pasting keys into AI chats, and using one master key for everything. But on the professional side, we see .env files, configured.gitignore files, and ultimately, secret managers. The absolute fundamental rule here is separating your code from your configuration. Your code should only ever contain the instruction to read a secret, never the secret itself.
Now, while platforms like GitHub offer amazing tools like push protection and secret scanning to catch mistakes, these automated tools are a safety net, not an architectural strategy. Never, ever commit your .env file. Always create a .env.example file with blank placeholders so other developers know what variables are needed. The very first line of defense is a properly configured .gitignore file that ensures your actual secrets never even attempt to leave your local machine.
All right, Section 3. Least privilege and privacy. Access and data protection. Picture this, a massive 90% of the vulnerability blast radius often comes from granting unnecessary administrative access to a token that really only needed 10% read-only access. When you give an AI agent the ability to call tools or query databases, minimizing its access drastically shrinks that blast radius. If an AI agent only needs to generate text, it absolutely does not need admin rights to drop your production database. It's that simple.
And hey, privacy is just as critical as access. Under regulations like the GDPR in Europe, specifically Article 25 regarding privacy by default, we have a strict duty to minimize data exposure. Take a look at this list. Never paste real usernames, active keys, database dumps, or private health data into an AI prompt. AI coding tools use the context you provide them. If you feed them personally identifiable information to help debug a script, you are inadvertently leaking data to a third-party model. Always use synthetic, fake data for testing, for sure.
Let's hit Section 4, Secure Deployment and CI/CD Pipelines. Your environments must be strictly separated. Preview environments should use completely dummy data. Staging uses test tokens with strict limits. Production uses the real, live keys. You must use entirely different keys for testing in production. If you use the same keys everywhere, you're just inviting environment confusion, which, by the way, is exactly how a simple staging test accidentally wipes out a real, live database. Here is a massive supply chain risk to watch out for during deployment. When your CI/CD pipeline builds your app, it generates logs, right? Well, if you leave a debugging statement like console.log process.env in your code, you will accidentally print all of your powerful hosting secrets right into plain text in your build logs. Anyone with access to those logs suddenly has the keys to your entire kingdom. So be incredibly mindful of what your code outputs during the build phase.
Which brings us to Section 5, Incident Response and Handling Leaked Secrets. So the crucial point here is having an actionable roadmap when panic sets in. Step 1, detect the leak. Step 2, revoke the key immediately at the provider level. Step 3, rotate it by issuing a completely new key. Step 4, analyze your Git history and logs to see if the key was actually used. And let me be unequivocally clear about this. Merely deleting the key from the current file and doing a new commit is completely useless. The key is burned. You must revoke and rotate.
Finally, Section 6, Secure by Design, a resilient standard.
Let's zoom out and look at the Secure by Design philosophy and see how this builds a robust culture. Organizations like CISA and NIST emphasize that security cannot be an afterthought. It requires shifting the burden away from an individual developer just trying to remember all the rules and moving towards standardized, automated workflows. This means utilizing secure starter templates out of the box, employing automated secret scanning on every single commit, using short-lived dynamic secrets that expire automatically, and fostering a blameless post-mortem culture where teams actually learn from leaks rather than just pointing fingers.
Which leaves us here. The incredible speed of AI coding is only an asset if your foundation is secure. Take a hard look at the code you are writing today. Are your secrets separated? Is your data minimized? Is your current project truly secure by design, or are you just one automated scrape away from a total disaster? Think about that before your next commit. Thank you for joining this analysis, and keep building securely.